We're going to be taking a look at this lab, method-based access control can be circumvented. Let's focus on that phrase, method-based. When we're creating HTTP requests, they come in different flavors or methods. For example, GET request, POST request. These are the two most common, but there are other HTTP verbs or methods that can be used as part of a HTTP request. For example, we have delete, options, patch, head. These are all HTTP verbs or methods that can be used. As mentioned, the most common that you'll see are GET requests and POST requests. In fact, anytime we type a URL into the browser, that's a type of GET request. The implication with the title here, method-based access control, is that the access control is based around the HTTP verb being used. Let's read through the lab guidelines. This lab implements access controls based partly on the HTTP method of request, so whether it's a GET request or a POST request, for example. We're then given some administrator credentials to explore the lab, but the objective here is to log in as a regular user, Wiener, with the password Peter, and exploit some vertical privilege escalation to make that user an admin. So without further ado, let's fire up the lab. So the first step here is to log in with the administrator credentials, administrator, password, admin, login. Once we're logged in, we'll notice there is a link to the admin panel. And in the interface here, we have a drop-down box that allows us to upgrade regular users to admin users. For example, if we select the user Carlos and choose upgrade user, we now see that Carlos has been promoted to administrator. Now, our objective is to make Wiener an administrator, but obviously doing it through the admin panel would be cheating. We're just here so we can get a feel for how the website works. Taking a look in Burp Suite, we can see that a POST request was created to the endpoint /admin roles. And we see we get a 302 response, really indicates that the page has been found and that the operation was successful. Now we're going to log out of the admin user and log in as our regular user Wiener with the password Peter. And we're going to see if we can submit this POST request on behalf of the regular user Wiener. Now, what differentiates a request from a regular user from a request from the admin? It's this session cookie. So we're going to send the request to /admin roles to the repeater, but we need to change the session ID to that of the regular user. So if we check out the GET request to the account section made by the regular user Wiener, we can take the session cookie of Wiener and we can apply that to the admin request. So if we delete the admin session cookie and use Wiener's session cookie, well, now this is a POST request that's really being sent on behalf of Wiener rather than the administrator. So what happens if we replicate that same POST request, but on behalf of a regular user rather than a known admin? Let's click send. We get the response unauthorized, as you might imagine. We're not an administrator, so we should not be able to promote other users to administrators. Now here is where the exploit occurs. The backend is only checking POST requests for rights to access this particular function. Let's see what happens if we change the request to GET. Now this won't work immediately. We get the response missing parameter username. Note that we don't get rejected immediately. The problem here is not that we're not authorized. The problem appears simply to be that we don't have the parameter username. And the simple idea here is that parameters in GET requests are sent differently to parameters in POST requests. So in a POST request, parameters are sent as part of the HTTP request body. You can see an example of that here. Whereas in a GET request, there is no body because it's essentially something you type into the URL bar of the browser. We therefore need to include our parameters as part of the URL. That's where a query string comes in. So a query string in URL terms is anything after the question mark. So we're going to hit the root /admin roles. We can simply take these parameters here and we can include them as part of the URL. So we have /admin roles, question mark indicating the beginning of the query string. Then we have our parameters, username equals Carlos and action equals upgrade. Of course, we want to change the username from Carlos to Wiener. Now, just to be clear, there is no difference between making this request in Burp and simply visiting this URL in your browser. If you want to solve this lab quickly, all you actually need to do is copy and paste this particular URL into your browser /admin roles, followed by the information contained in the query string, i.e. the request parameters. Let's send that. We get the same 302 found response. If we navigate back to the lab, you can see we get the message, congratulations, you solved the lab. Okay, so what happened here? What exactly was the vulnerability? Well, the web app was clearly only verifying post requests for valid credentials, i.e. a valid session token. We sent a GET request, it didn't bother checking the GET request. So what is the mitigation here? Now, it might seem that the obvious answer is that we should simply check all HTTP methods. So it doesn't matter whether it's a GET request, a delete request, or a patch request to /admin roles. We need to check all of them for verification. And that would secure our application, but the way that modern web apps work, for a single endpoint, for example, /admin roles, it's fairly typical that only a single HTTP verb will be accepted. So in most cases, in a secure web app, if I try to send a GET request or simply type /admin roles into my browser, I'm actually going to get a 404 response from the app. In other words, this route should only exist for a post request. Now, in some cases with web apps, you could get the same route responding to two different HTTP verbs. So you could get the same route that responds to a GET request and a post request. But usually in that case, the two different HTTP verbs will perform different functions. So although the name of the route's the same, for all intents and purposes, it's a different route. So the simplest way of locking this down is if we have a post request that's allowed to /admin roles, we only allow a post request. If anyone tries to send a GET request or a patch request, we simply return a 404 and say, hey, look, you're in the wrong place. Don't know what you're trying to do. This is not the right thing. Hopefully it also goes without saying that the security of your app should not be dependent on which HTTP verb was used. You could code something that says, so long as it's a post request, then it's permitted. But the reason why that doesn't make any sense is because you've seen how easy and arbitrary it is simply to repeat the request here and change it from GET to POST or from POST to DELETE or any other type of HTTP method. The HTTP verb here is really designed to give a bit of information regarding the reason for the HTTP request. This is certainly not designed as a security option and it should not be used as such. All right, hope you found it interesting. Thanks very much for watching. Catch you guys in the next lab.